Hey everybody, and welcome back to my channel. So now we are finally getting into the GASP from Scratch Animation Blueprint series. So welcome to the first official episode of that series. I know I put out an introductory video yesterday just because I wanted to get people hyped for it, to try to, get them to look forward to seeing what's going on as far as the notes that I have and the things that I've kind of uncovered with the animation blueprint so far. So I will say, unfortunately, as of this video, I do not have everything uncovered. However, I do have, a lot of cool stuff to share and to try to, spark discussion with what I've found, and hopefully with a lot of the stuff that I do mention throughout this series that I've uncovered, that hopefully I've kind of hit the mark or kind of hit some like eureka moments for, what's going on in the animation blueprint. So right now we are in our previous GASP tutorial. I still have this from when I did the GASP from Scratch character blueprint series where I have my stuff up and running, but now we are ready to move in the animation blueprint where we are going to recreate the stuff from scratch. So I'm going to hop out of here now, and what we're going to do is we are going to go into character content, characters, mannequins, and animations, and we're going to open up the ABP Mani, because in the ABP Mani, that's where all the animations occur anyway within the third person blueprint. So we're going to make all of our changes in here, and as you can see, I already had the tab open, so it was just a quick load for me, but we are finally able to get in here now and start making some progress in here. So like just how we did in the character blueprint series, we're going to basically like copy, sort of like frame by frame, or, basically one-to-one of how the GASP has their animation blueprint set. So we are going to start in the event graph, because most of what I understand so far is pretty much what's going on in the event graph. That slightly dabbles into the Anim Graph for certain things, because when we do set up some essential values, that we will have to go into the Anim Graph at one point to make some nodes. So let's go ahead and get started and go over the animation blueprint within the third person template. So as you can see with what I have up, that you see the basic default stuff of what is going on. So in the traditional sense of a third person blueprint, up here we basically cast to our character, which is a default character built into Unreal Engine 5 that will give you kind of like the base nodes or variables and other references within that class. So basically it is an actor class, like default class, that we then make a character reference off of, and then we grab the character movement and then set a movement component variable. Then what we end up doing in the traditional sense is we basically do the update animation, which is essentially the event tick of the animation blueprint, similar to, like I said, similar to the event tick in the character blueprint. And then into here we pass in a validated get node of our character reference. So essentially with the reference, in order to get a validated get, you would essentially drag in the get node of whatever you need to validate, and you would right click and do a convert to validated get here in order to get that that specific get node. However, as far as I'm aware of, this only works with object type references. So, if I believe with a movement component, if I try to do it here, okay, so I can, because it's based off of the object type reference. However, there are other variable types. I believe, for velocity, you could see that there's no validated get, or, ground speed, there's no validated get. So it's pretty much for object type reference nodes or components off that reference. So once we validate it, we then go into our sequence to where we get our velocity that we then convert into, like we decompose into basically a magnitude where we get like the horizontal speed by converging our X and our Y values together to then get our overall ground speed. So that's why when you do like a print string off of this, that your ground speed, it only shows one like one vector type, or not even a vector type, but one value that will rise and fall as we move, compared to the 3 different vector components of like velocity, because we're converging them into just one horizontal plane or value. And then in here, for our traditional third-person blueprint, we get the current acceleration of our character, and we check to see if we're not moving. And then what we have to also do is we're checking if our ground speed is greater than 3, and if both of these are true, then we should be moving. And we use this in order to basically prevent small velocities from triggering animations, so that's why they do it in this way in a basic sense. And then lastly, we get the falling state. So with that being said, as far as looking over the traditional way of the third-person animation blueprint, what we're going to go ahead and do now is we are going to start modifying this so that way we can get our essential values up to speed. So the first thing we are going to do, and I'm going to, jot down some notes in here and go over them of like kind of stuff that you would want to use in an animation blueprint as far as my research, has shown. So I'm going to move temporarily the initialize animation over, and what we are going to do is I'm going to select all of these, and I'm going to collapse to function, and I'm going to call it set references. Because, one of the reasons why I'm doing this is to make sure that we maintain that 1-to-1 ratio of like how the GASP Animation Blueprint does theirs, but also too, this is good practice for when you want to initialize different stuff, at the beginning of the game or whatever, right? So now that we got that, I can move basically this back into place just like so. And in the animation, in the set references function, one of the things that we want to do and go over is, first of all, we want off the get owning actor, I'm going to go ahead and delete that. On top of that, I am also going to delete the cast to character node, because one of the things that we want to do, which is something that the game animation sample project does, is we want to grab our BP third person character within this template. So what I am going to do is I am going to grab a cast to BP third person character, just like so, and we are going to tie that into our character reference. So what we also want to do is, since we have tied that in together, we do need to modify this character reference in here. So we want to click this character object type reference, and we want to grab the BP third person character. And what we want to do is we want to grab the object reference, because that was the original character reference. It was also an object reference. So we want to kind of match that energy, but we want to convert it to point directly to the BP third person character, just like how GASP points to the CBP sandbox character. So you will get this notification saying it will break connections and go through all variable instances that have character involved to change its type and recompile. We do want to do this because there's not that much going on. This is just a basic object reference that we are changing in order to point everything to our blueprint characters, so nothing really breaks here. So once we do that, the next thing we want to do is we want to right click into here and do a try get pawn owner. And the reason why I'm changing it to get pawn owner, and I'm hoping that, for any sort of Unreal Engine 5 veterans that may correct me on this, as far as my notes are concerned, as far as the difference between a get owning actor and the try get pawn owner, is that for get owning actors, the notes that I have is that it's a general purpose node for getting the owning actor of a component or widget and can return any actor. The context for this node is typically used within actor components or widget blueprints. So, on return type, it returns an actor reference, which is a more general type. This means that the actor could be anything derived from a base actor class, such as a pawn, character, static mesh actor, etc. The usage that I have for it you would use this node when you're working with a component or a widget that is attached to an actor and you want to get a reference to that actor that owns the component or widget. So an example use case, if you have a health component attached to a player or enemy actor and you want to access that actor from within the component to apply damage or check status, you would use getOwningActor. So there is more at play. However, the other context that I have for the try-get-pawn-owner in this instance is that it's more or less specific to animation blueprints and returns the pawn that owns the animation used for accessing pawn-specific functionality. So the context for the getPawnOwner is that the node is specifically used within animation blueprints, because I think this is also used in the game animation sample project as well. Let me see, since I have it up, since I've been doing some research. Yeah, so we have try get pawn owner in here. So, you know, the return type that I have in my notes for the pawn owner or the try get pawn owner is that it returns pawn reference. Since pawn is a subclass of actor, this node is more specific and will only return actors that are pawns, including characters which are a subclass of pawn. So the usage of this node is you would use this node when working within an animation blueprint where you would often need to interact with the pawn that is being animated. So an example use case, if you are animating a character and need to access the pawn to get its movement speed or other properties for use in the animation blueprint, you would want to use the try get pawn owner. So in this case, because of all the references that we'll be getting and utilizing throughout the animation blueprint within this series, we want to stick with how the GASP has it in there, where we do a try get pawn owner, since it is more specific to animation blueprints and helps us get things like movement speeds or velocities or other properties, right? So that's pretty much the rundown of the difference between doing the get owning actor and try get pawn owner. So another note that I have as far as, you know, the set references that I made note of is that the function for set references caches the references, you know, to the third person character, or, you know, in which case in the GASP, the CBB sandbox character blueprint, and the movement component or the character movement component for use across the animation blueprint. This also enables us to use thread safe property access calls for these references. So there is a video that I made in discussing how to make functions usable within motion matching databases. And you cannot have direct casts, you can't have other function types like these in there. You have to make variables or set references to like character movement or character and other stuff in there, to where you would then call like specifically mathematical functions such as things like velocity and other stuff that will be able to be used in a pure function that you can make thread safe in order to be called in the motion matching database. So that's why this is also important by setting references in here, so that way when they're called later in other functions or when we start making pure functions within the animation blueprint, that we can ensure thread safety, especially when you are making video games and you want your functions to be thread safe and only utilize, like, you know, specific gaming threads, stuff like that, etc. So that is the basic rundown of what we are doing here in the set references. So we can go ahead and compile and save this now that we've made our changes. And I'm going to close out and go back to the event graph, and I'm going to just modify this a little bit just to kind of like spruce it up. So just like that. So now that we got our set references, we can now go ahead and go through the updating essential values. So this is where it's going to be kind of long, where I try to do my best to go over a lot of the stuff that is happening within the GASP update essential values function that they have. So first thing we're going to do is I'm going to highlight all of these and I'm going to collapse them to a function, and I'm going to call this update essential values, just like that. And then I'm going to move that over here, to which we're going to go into here And what I'm going to do is I'm going to do another collapse for the moment, because we want to keep these at the moment, because while we're dabbling in the third person template, we still want our basic animations and stuff to work within our third person character template. However, you will notice that as we go through this update essentials value, that you will notice that we will utilize or reutilize some of these to where we can eventually like get rid of them, like once we actually call them elsewhere. So what I'm going to do is highlight all of these, and I am going to then right click and collapse to function, or it should, oh yeah, because I have a sequence. So let me do this instead. I got to highlight the sequence node and then collapse to function. And then I'm going to call it default anim values, just so that way we can kind of have it off to the side, more or less up here, just so that like I said, that our animations still work while we are dabbling in the animation blueprint, getting our essential value set up. So the first thing we are going to do now that we have that set, and actually, let me go ahead and move my notes over here so that way we know what's going on, and for y'all to pause the video and capture these notes. That way you know, too, what is going on in your third-person template. So, now that we got that, the first thing we are going to do now is we are going to get our character transform. So, this one is very basic, very simple. What we are going to do is we're going to grab our character reference. So from here, we are going to then get our actor transform, and then off of our actor transform, we are going to now create a variable off of that, and we're going to call that character transform, just like so. So what's going on here, essentially what we're doing is, from our character, because we're trying to use our reference to our character blueprint here, you know, the stuff that would be in here, or a part of our character in general, like the mesh where we get our transform here or out in the world, is that we want to get our current actor transform, which consists of the character's location, their scale, and their rotation, because we want to capture or cache this transform, just to mainly have it for convenience use, for if we ever have to use it for every reason. As far as I'm aware of with my research at the moment with the animation blueprint, currently I do not see character transform really be used elsewhere, besides the next thing we're going to be working on. So this is just mainly for caching just convenient data in order to ensure, like, you know, thread safety throughout, you know, the functions and stuff that we use or create. So what I am going to do then is, let me copy my comment here, and then again, y'all can pause it if you want to jot this down so you know what's going on here. And then what I'm going to do is connect the sequence pin to that. So now, as far as this is concerned, if you want to see how this is actually looking, you know, we can do a print string, and we can connect the character transform into it, so that way you can see the data and how it prints out in real time. So you'll notice that as soon as we compile and save, it is getting our character transform. However, it's only showing the character transform within the space. If we hit play, you'll notice how our transform then updates with its actual proper values, you know, on the screen. So you'll notice that our location, which, you know, which is the translation, is that we are currently positioned at the X of 900, the Y of 1110, and the Z of 92. You'll also notice that our rotation, you know, as we look around and do certain things, that it updates on the Y because of how, or not on the Y, but the yaw, which is the Z, because we're rotating along the Z axis. So that's why you see it updating like that. The pitch would be our Y axis, and that would be as if our character is leaning upward or leaning downward, that we would get a positive or negative number. And then our roll is if our character was like doing a barrel roll, like as if you were in an airplane. Like, you know, I know you know the memes of do a barrel roll, but that would essentially indicate that we are rotating along the X axis doing an actual roll. And then lastly, you could see that our scale is a 111 because that is what our current scale is for our character. So that is pretty much a basic rundown of what the transform is where it's getting your current actor's location, it's getting its current rotation, and the size of your character, which, like I said, will be used in the next thing that we'll be doing. So, next thing we are going to do is we now have to set up our root bone information, you know, to make from our skeletal mesh, so that way we can make sure that it's transformed accurately, you know, considering the default rotations applied, you know, in Unreal Engine and other possible offsets. So, you know, by storing the root bone transform and applying adjustments, we can ensure that the system ensures that our character's animations are applied correctly. So, what we're gonna do first is there is something we do have to grab. So it is going to be a plugin because we do have to do a get console variable, and it is going to be a bool value. So in order to get this, what we do have to do is open up edit, and we have to go to plugins. Within your plugins, what you want to look for is animation warping. So this plugin is going to contain a variable name or a console command that we do need to grab, because that is going to be something that we set as a variable. So go ahead and check off animation warping and then do a restart. So I'm going to hit restart and I will be back once it's finished. Alrighty guys, I am back. So now let's go ahead and get into it. So one of the things I'm going to do first before we truly get into it is I'm going to update the category for our transform, because as we make variables now, we do want to keep them under a different category so we know what they are. So in the game animation sample project, the category that they have for all these variables would be under essential values. So essential values, just like that, just so that way we know where to keep all the current or all the variables that we make throughout this video. So now what we want to do is we're going to right click into the animation blueprint. We're going to do a get console variable, and we're going to do Boolean value, because what we're trying to do is we are trying to grab the Boolean value off of a console command that is contained within the animation warping plugin that we just got. So what we are currently looking for, and I'm going to copy and paste it in here, is the a.animnode.offsetRootBone.enable. So basically what this is doing is we are checking our offset root bone to see if it's enabled or not, right? So basically, we are going to feed it into a branch, and if the offset root bone is not enabled, what we will then do is we're going to get the character transform, and it's just going to be considered our root transform, or basically our offset root bone in a sense, right? So that's pretty much what we'll be doing if this is enabled or not. If it is enabled, then that's when we have to then set up our Anim Graph and provide an anim node reference to where we can then grab an offset root transform, where we'll then be remaking the transform and then getting ourselves a proper updated root transform. So to show you what I mean, now that we have the console variable, what I'm going to do is off of the return value, I'm going to promote to variable, and I'm going to call it the offset root bone enabled. Just like that. And then off of the root bone enabled, I'm going to grab a branch node, if I can ever spell correctly, and we are going to connect the offset root bone enabled. So what will happen is when we go through our animations and we have this offset root bone enabled, it will then pass in true or false, you know, depending on whether we have it enabled or not enabled, into the set offset root bone enabled variable. And then if this is true or false, it will then pass into the branch to where we will then grab our character transform. So let's work on the false first. We'll grab our character transform, and we're going to create another variable called root transform. I got a camel case it just that way it can get the proper spacing. And that is pretty much it for the false. This is where it ends. So, like I said, so what will happen is whether this is enabled or disabled, it will pass a true false value in here. And if the offset root bone is false, then we are just going to define our base root transform that our character just pretty much has. So it just essentially matches or sets the animation's root to match the character's current world transform. So its current location, its current rotation, its current scale, you know, as our root. So that's what we're trying to indicate here off the false. So before we continue on the true branch, what I am going to do is I am going to jot down my notes for y'all to be able to copy. Not like that. Let me do this. All right, and then let me move those briefly just to be able to capture them properly. All right. Perfect. So then let me grab my root transform note that I have for y'all. And move that back to group. Just for y'all, so that way y'all can copy it down whenever you decide to pause the videos. So there we go. All right. So now what we are going to do is work on our true path. So first thing that we do need to do, and we're going to make this very simple, is we are going to, well, let me drag these in here under the essential values real quick. And what we're going to do is we're going to grab our root transform and we're going to grab it as a set node. And I'm going to set it pretty far away because what we have to do now is we have to create an anim node reference in order to get the transform off of that, break it, and then remake it, and then pass it into the root transform. So in order to do that, we need to step into the Anim Graph for the moment. And what I'm going to do is I'm going to move the output pose a little bit away, just like so. And I'm going to disconnect this part because I don't want anything else in here getting messed up at the moment. Like I said, just to be able to maintain our current animations for our animation blueprint. So off of here, what we now need to look for, because now we have animation warping plugin enabled, because I believe you need that anyway in order to see this, but don't quote me on that, is now we have to get an offset root bone function, which is right here under the MISC. So it looks pretty sad. You only got a source and an output. However, this is what we want because there is a lot of things that we do have to do to it in order to make it look like the one set in the animation blueprint for GASP. So currently what I'm going to do first is just to kind of get things going, get things steady, is I'm going to just plug it back into the output pose. And what we're going to do is we are going to set some things. So actually we don't have the things first. Let me check something because I believe we want to, it's expose this pin. Yeah, we want to expose this pin and then do the same thing for the rotation mode. So basically for the translation mode, which is the translation behavior mode, and then the rotation behavior mode for our offsets, we want to expose those as pins because we are going to make adjustments to them or at least set functions to them later. However, right now we want to just expose them as we work through this. The next thing we want to do is underneath our settings, this clamp to translation, if I remember what the thing is, velocity, translation velocity. As you can see, this is to define whether the limit of the offset's translation interpolation speed to the velocity of on the incoming motion. Enabling this prevents offset sliding when there's little to no translation speed. I got to do more research for that for you guys, and what I'll do too is like kind of pin that in the comments once I get more information on that. But basically, I think this is also a way to kind of prevent unnecessary movements or sliding or whatnot from the offset bone or like our current, transform. So with this, what we want to do is we want to bind this currently to our should move. because in the game animation sample project, they have their own is moving functionality that is similar to the should move. And we're going to clamp the translation velocity to the should move for the moment, just to have a similar thing to what GASP has, because they're essentially do the same job. They're just done differently, because in the game animation sample project, they're getting a little bit more detail with the movement boolean for this clamp to translation velocity. Then the next thing we got to do, which is pretty important, or we won't be able to call this within the event graph, is we have to give it a tag. And what they have called it is called the offset root, just like that. So we have camel casing, or at least capital O, capital R for this, and we're going to hit enter. So now you'll notice that when we did that, it now gives this offset root bone function, or not function, node, miscellaneous node, the name or tag of offset root, which will allow this, as you can see, this node can be referenced elsewhere in this Anim blueprint. So this is one of the things that we need to do to be able to call this within our update essential values in order to be able to get transforms off of. So then lastly, that should be it. Yeah, everything else is currently disabled and unbounded. So this is going to be the basic thing that we have going. However, as a warning, what we want to do is we want to quickly change the translation mode and the rotation mode to release. And to show you why, if we look at interpolate, you can see that what it's trying to do is move our character. However, with interpolation, basically what interpolation does is, say that you have 2 points like on a graph, right? Say you have a point at 0, 0, and say you have another point at 2, 2. Well, you know, if you recall doing basic math classes with those graphs, right? How it's like, okay, you got to connect those 2 points, and then you would draw a line from the 0, 0 point to the 2, 2 point. The interpolation part of that is the guessed data in between that 0, 0 point and the 2, 2 point, of like the best guess or best closest approximation to how you get from the 0, 0 to the 2, 2. So what this is doing with the interpolation, with the translation mode and the rotation mode, is it's trying to give a best guess. So it's going from, you know, its 0.00 to the 0.22, and then giving its best guess on where to start moving once you actually like release your button. So that's why you see them jumbling around, but then shoot to that point when you're done, you know, currently moving. So in order to get back our point, you know, for translation or rotation, we want to set it to release, because you'll see that the release the offset and stop accumulating the mesh's components movement delta. In this mode, we will blend out the offset. Basically, it's just, in simple layman's terms, it just allows us to move freely without any sort of like interpolating of data, because what we are going to be doing is doing some accumulation and releasings of certain pure functions that we'll be doing that will be called into the root offset bone in later videos. So now that we have that basic offset root bone set, we can then go back into the update essential values and then work on our second part of the root transform. So if I right click into the graph now, I should be able to grab the offset root. And you'll see down here at the very bottom, note reference offset root. So this is essentially why we had to give it a tag, so that way we can call this, because now that we have this node, we can drag off of it and then do a get offset root transform, because again, what we're trying to do, as you can see, we're trying to get the current world space transform from the offset root bone Anim Graph node. And you can see that the target is from the animation warping library. So we wouldn't be able to get this node to be able to modify our transform to then update our root transform if we didn't get that plugin. So while we have this, let me go ahead and grab my 2 comment nodes that I have for this, you know, for y'all to jot down and be able to reference in your own project. So let me go ahead and move here and then put that into there. Just like that. And now that we have that, we can go ahead, and what we're going to do is we're going to break this transform, because what we want out of here is we don't want the scale, we want the location and the rotation of the transform for our offset root bone. So let me just group that. So now that we have the break transform node, what we are then going to do is we're going to break the rotation. So I'm going to then do a break rotator. And what we want to do, and it's kind of weird why they want it, because you can essentially just go from rotation to make transform. But there's certain things that it does as far as caching and referencing that we're breaking it currently like this. So what we are going to do real quick is then do a make transform, and we're going to break the rotation, and we're going to put the roll into the roll, the pitch into the pitch, and the yaw into the yaw. And then with our location, we are going to move it in there, and we're going to keep our scale the way it is. So it was kind of confusing why we couldn't just go straight from transform into, you know, the root transform set node up here. But I believe what's going on is that it's trying to get the individual references within this break rotator, because we're not always pitching and we're not always rolling. However, in certain cases that we end up rolling or pitching, that we get those minute changes and within the transform, you know, when they actually occur. So that's kind of what I believe is going on, and that's why I believe while we do a break rotator just like in the game animation sample. However, you know, if somebody does have, you know, more experience in handling this, I would definitely love to hear your comment in regards to this, to kind of have a better understanding as to why they are separating it using a break rotator. So then, like I said, we are then setting a new transform. Oop, didn't mean, I thought I copied the new node. So then we set the new transform, and then we then pass that transform into our root transform. So going based off of this, kind of what I was saying, that if the offset root bone is enabled and that is passing in true, then we grab the offset root anim node reference that we made in the anim graph and have set, and we're going to grab the root transform from that anim node offset. We're going to break it down to just get the minute changes of the rotation, and then pass the location and rotation into the make transform, and then set that into the root transform. So that is how we are basically doing that setup as far as this. So to kind of go over, you know, what this whole series, this thing does from my notes. So this setup is all about making sure that the root bone of the skeletal mesh is transformed accurately, considering the default rotations applied in Unreal Engine and other possible offsets. By storing/caching the root bone transform after applying these adjustments, the system ensures that the character's animations are applied within the correct positional and rotational data, leading to smoother and more accurate animations. So if we look back at the dev note that they have, you know, in the original GASP, that it caches the root bone transform from the offset root bone node if possible, storing the offset this way instead of using the get socket transform function ensures a more accurate value. Since skeletal meshes are rotated -90 degrees by default in the viewport editor, an offset is added to make angle comparisons against other transforms easier. So that's why I believe that we do break rotators and stuff like this, because of how the dev note is better explained with the notes that I managed to gather. So with that being said, I am going to then copy and paste my comment, and this is what I was reading off of just because of the fact that I had this as part of my notes. And let me move some stuff over real quick just so everything looks nice. Move that in here. All right. And then for y'all to be able to copy that down and see it, I'm going to run through it real quick. So as you can see, the setup is all about making sure the root bone of the skeletal mesh is transformed, considering default rotations applied to Unreal Engine and other possible offsets. By storing caching the root bone transform after applying the adjustments, the system ensures that the character's animations are applied with the correct positional and rotational data, leading to smoother and more accurate animations. So now that we got that, we're going to go ahead and suit up our pin into the get console variable. Let me go ahead and make that pin connection there. So now we can move on to the next part. So the next part we're going to be working on is caching acceleration data, and it's pretty much for future use stuff because not all of the acceleration data will be used or applied within the animation blueprint. However, it is useful information to have just in case you do need to call and use it. So what we are going to do first is we are going to go into our references within our variables, and we're going to drag out the movement component. And off of the movement component, we're going to grab our current acceleration, and we are going to drag off it again and get our max acceleration, just like that. So we have both pure function nodes. Actually, I need to move this up a little bit because I do have a note for it, just for y'all to have. So as you can see with the get current acceleration, that it retrieves the current acceleration vector from the character's movement component. This acceleration represents how much the character's velocity is currently changing due to our movement input. So what we're going to do is we are going to promote our current acceleration to a variable called acceleration. And I'm going to move that into essential values. And I'm going to move that up, and I'm going to add my note to it because what we're doing here essentially is the acceleration vector obtained in the previous step is stored in this variable as you see that we're getting here. So what we're going to do off of this is we're then going to grab the vector length, and we're getting the entire vector length, not just the XY. Because what we're trying to do is calculate the magnitude or the length of the acceleration vector, which gives the overall intensity of the acceleration regardless of direction. So that's why we're grabbing our vector length. And off of here, what we're trying to do is we are going to get a division node, not a subtraction node, a division node. And we are then going to grab our max acceleration and plug it into here. Because what we are trying to do here is we want to get an acceleration amount. Basically what we're trying to do is normalize the acceleration value by giving us a 0 or 1 representation that is stored in the variable. So to see how this actually looks, let me grab a print string for y'all. So to show you how the acceleration node looks when we do this, and I'm going to then create a new pin, plug it in here. So as you can see, we get the vector representation of our acceleration. So once I start moving, you can see how the numbers shift because our maximum acceleration within the third-person character blueprint is 1500. So if we're going 1500, negative positive on the X, or negative 1500, positive 1500 on the Y, that's what it's getting. So with what we're doing is then we're converting it to a single value. So to show you how that looks, I'm going to drag off the vector length and go into string. So as you can see, it goes down from 3 points to 1 point, and you can see that we just get an overall value of 1500. So now that we've gotten that, we then plug it into here to the division node because our max acceleration is 1500. So when we do get up to speed to 1500, that it will then divide by the max, which will give us a 1. If we are not moving, it's a 0. So as you can see, when we start moving, we then have a 1 value to represent that we have an acceleration amount. When we stop moving, it converts to 0. So what we are then gonna do is off of this, so let me actually grab my notes real quick for y'all to jot down so you could see what is actually, to recall what is going on within your project or your notes. So let me move that up here. And then for my division node, and then once we have that, what we're going to do is we're going to, off our division node, promote it to a variable, and we're going to call it acceleration amount, because we want to capture that 0 or 1 value. So once we have that, I'm going to plug it into the acceleration into the acceleration amount, and then I'm going to prettify these up real quick. All right, so now that we have captured our acceleration amount, just like so, and we're getting our 0 or 1 values, what we're going to do now is we're going to then off of the acceleration amount check if we are greater than 0. Because what we're trying to indicate for later use or for future use, if you decide to use this, is to check whether or not we have like acceleration, which can be useful for animations depending on how you do it. However, so far I've not seen a very good representation of how you would use it within GASP, because they do a lot of good stuff, currently with the databases and stuff that they have. So, trying to pretty these up, so I'm just like messing around. So now let me go ahead and put the comment here for y'all to jot down. And I'm going to move that up here. So now lastly, what we are going to do is off of the Boolean, we are going to promote that to a variable, and we're going to call it has acceleration, because as far as a 0 or 1 value is concerned, we either have acceleration or we don't. So I'm going to then plug that in here, and then I'm going to then copy my note and plug it into here. So that is essentially it for this section, where we have gathered our acceleration data just for any sort of future use that we may have for it. So go ahead and put that out here, put that down a little bit. All right, and then so basically with what this is doing, the entirety of this function based on my notes is that, again, we are caching acceleration data. This entire process is designed to cache useful information about the character's input-driven acceleration. This includes both the raw acceleration vector and a normalized value indicating how significant the acceleration is. The future use part of it, while not all of this data might be immediately used in the animation graph, having it cached makes it readily available for other features or systems that may need it. So for example, it can be used to blend between different animations depending on how much the character is accelerating, or to trigger specific effects or sounds based on the acceleration. So according to the dev note that was left behind, it caches important information about the character's acceleration, which is the input acceleration applied by the movement component, not the physical acceleration. Although not all the values are currently used in the graph, they are important to have on hand for additional features. So I am going to now copy that comment and move it into here just for y'all to be able to pause and grab for your project. Yep, I think the spacing looks good. And I'm just going to float through it just so y'all can see what is being said. So like I said, entire process is designed to cache information about the character's input-driven acceleration, yada, yada, yada. get specific animations, stuff like that. So again, just kind of pause the video when you need to be able to grab these. I know my notes are kind of long, but there is a bunch of stuff to go through with the animation blueprint. So it is important that I do have these notes so I can better explain what's going on to y'all. So I'm going to compile and save this, and let me move my acceleration stuff in the essential values. And now we can work on the last long part before we get into the last 2 bits. So now what we're going to be looking at is caching velocity data. So basically what we are going to do is I'm going to open up the essential movement data, or actually, yeah, let me open those both up, because we will now be taking part of the default third person like animation blueprint data to be used within this. So what we're going to do is I'm going to now grab the velocity out of here, out of the essential movement data, and I'm going to then promote it to a variable called velocity last frame. So off of this, didn't mean to do that. So what this is doing essentially is it's getting our current velocity at the time. So whether we're idle or currently moving, it is getting that specific frame's velocity and passing it into this node that we then set, because we will then call that last frame's velocity to then subtract it from the current velocity at the time to then get the next velocity unit or number or amount, because this better smooths out the animations by getting the per frame instance that the velocity is being captured at. So to kind of go over what I have with these comparing to my notes is that this retrieves the current velocity of the character from the character movement component, and it contains both the direction and the speed magnitude of our of our character. And then this stores the character's velocity from the previous frame and is essential for calculating changes in velocity, which is used to determine acceleration and other factors. So I'm now going to move velocity from essential movement data down into essential values underneath acceleration. And then I'm going to move my velocity last frame in there just to have it now in the essential values. So what we need to grab now is the character movement component, because now we need to recapture our velocity, at this current point, because what it's going through is one frame doing this and the next frame doing, the other part of velocity, or capturing the new velocity. So this should look pretty familiar with what we're about to do, because it is pretty much similar to how the third-person character templates animation blueprint works. So we're off of here. The movement component is we're going to get velocity, if I can ever spell, and we're going to get the actual vector node get velocity. And then off of this, we're going to grab our velocity within essential values, and we're going to set the new velocity of our current grabbed velocity when our character starts moving. And I'm going to plug it in just like that. And then just like how you would see off the third person animation blueprint, is off of here we are going to grab the vector length XY, because what we're trying to do is we're trying to basically like decompose or like migrate or converge the velocity or the vectors into a single value, just like how we did with acceleration. However, we want it on the horizontal movement of our character rather than grabbing the vertical, which is our Z, because we don't need that for this instance. We're trying to get our 2D speed or our ground speed. So off of here, what we can then do, so you'll notice in the game animation sample project that they have speed 2D, which is here essentially ground speed. It is literally the same thing. That's why I said this should look familiar, because what we're doing is essentially getting the movement component, getting the velocity off of it, setting the velocity, returning the vector length, and then setting the ground speed according to our vector length XY. So, and you'll see that if we hop into the default Anim Graph, it is literally what you see here. So now that we are essentially grabbing this, what I am going to go ahead and do is I am going to delete this, because now we no longer need it, since we are now calling it within the update essential data. So, or at least we should be. So I do unfortunately have to add a pin or our stuff won't work. So let me compile and save. So now that we have that, or actually before we move on, let me go ahead and add my notes for y'all to be able to jot down. And then move this over ever so slightly just so I can get the new notes. Oop, come on. All right, so now that we got that, now we can move on to the next part. So, which is going to be similar to how this is working with our should move. However, we can't really delete the should move yet, because then it can mess up some other stuff. So off of the ground speed, what we are then going to grab is greater than symbol, and we are going to say greater than 5. So what we're doing is in the default anim values, we're trying to make sure that our ground speed is greater than 3 to prevent, incredibly small velocities from triggering animations, which is similar to what is going on here, because we're trying to not trigger, those slight animations from our slight button press or our slight, small speed. So then off of that, what we're going to do is we're going to right click and promote it to a variable called has velocity, because it's basically equivalent to the should move, should not move. So I'm going to go ahead and put my comment in here for y'all. So as y'all can see that our ground speed, if the ground speed is greater than 5, the has velocity boolean is set to true, which means that the character is considered to be moving, and a threshold like 5 helps avoid detecting minor unintentional movements and triggering, animations. So now that we have that, we can go ahead and go into the next part, which is one of the things that we kind of need to have like a lengthy talk about to know what's going on, because it could look confusing when you see it in the actual game animation sample project. So the first thing we're going to do is we're going to grab, actually let me move my has velocity here, and we're going to grab our velocity and we're going to grab our velocity last frame, because now this is what I'm talking about, where we have to now get those changes, or those minute changes, in order to have better, smoother, more fluid movements when it comes to the motion matching and stuff like that. So from the velocity, you're going to get a subtraction node, and you're going to then put you're going to connect the last velocity last frame into that. So what we're doing is we're getting our current velocity, as you can see, that is set here when we actually start moving, and then the last frame's velocity. So what would happen is if the velocity is currently 0, then it's caching this at 0, but as soon as we start moving, which will then be detected by this because it's 0, 0.0 whatever here, but when we start moving, then it has to go through a looping process to then come back here, get the new velocity and set it as the last frame. So while this is at a 0.0, this can then shift to a 1.0, but then has to then loop around before this velocity last frame is set to a 1.0, when this changes to a 2.0, and so on and so forth. So that's what we're kind of doing here, is if that velocity is at a 2.0 and our last frame was then set to 1.0 from our movement, then we then have a 1.0, vector across the board. So off of here, what we got to do is we're going to get the world delta seconds, and we're going to get a max float node. So essentially what we're doing with this, and we have to set it to an incredibly small value like 001, just kind of how they have it. So here what's going on is that, we're going to end up dividing the value that we retrieve in here by this, because we're trying to, as the time passes between frames, we want to then divide the velocity by the delta seconds to ensure that the time value used is not too small, and preventing the division by using this by 0 or overly large acceleration values. And then we are going to then get the appropriate velocity acceleration data that we need in order to ensure smooth animation transitions. So what we're going to do off of this is we're going to get a division node, and we are going to then plug that into the division. And let me set that over here. And then off of our division, we are going to then promote that to a variable called velocity acceleration. Just like that. And then let me grab my notes for it so that way y'all can see what is going on in here. And then once y'all have that, I am now going to plug in my node. And there we go. So now lastly, what we are going to be doing is off of the velocity acceleration, we are going to then transition into a branch, and we are going to check if we have velocity, right? So off of here, we're going to grab our velocity and check if that is true or false, whether it's a 0 or 1. And if it's false, we're going to do nothing. However, if it is true, what we are going to do is we are going to get our velocity and set this as a variable called last non-zero velocity. Just like that. So that's what basically is going on through here is, we check to see if we have velocity, and if true, then, if the character's moving, then we have velocity and it executes the next step. And then if the character does have velocity, the current velocity will be saved into the last non-zero velocity. This can be useful for referencing the character's last known movement velocity when the character stops moving. For example, when they become 0, we at least know what the last, non-zero velocity looks like, again, for smooth transitions. So I'm going to go ahead and paste my notes into here for y'all. And now we are pretty much done with this last long section. And what I'm also going to do too, let me back up a little bit more, is let me grab my big comment note that I have for this section and paste it in here so we can go over what it briefly is real quick. So this section is focused on caching the character's velocity, acceleration, and related values like ground speed. These variables are essential for animation blending and deciding when to switch between idle, walk, or run animations, and creating smooth transition between different character states. So as the dev notes state, it caches important information about the character's velocity, and although not all of these values are currently used in the graph, they are important to have on hand for additional features, similar to how the acceleration was up here. So now we are on to the second last part, which is going to be very simple to go through. So let me go ahead and add a pin up here. And what we're essentially going to do is we're going to grab the get console int value, just like this. And if you did the GASP from Scratch series for the character blueprint series, you should have seen where to apply the DCC variables or the data-driven custom variables that you can put into your engine in order to grab certain data or custom data that you can input on the fly rather than having to hard code them in C++. So the variable we want to get out of that, if y'all have seen it, is the DCC var database LOD. So what this is doing, and I didn't have to make any additional notes to this because it's pretty simple is what it's doing, where it is gonna, basically what we're doing is when we're gonna promote this to variable, and this is gonna be used, let me spell this out because I'm losing track of myself. So essentially what this is being used is to cache the value, that is set in here to be able to switch between the motion matching chooser table to swap between dense and sparse databases. This is pretty much it. However, one thing that you'll notice if you ever have checked that chooser table that chooses to play either the dense animations or the sparse animations is that it is a float value. I have not found it yet. I don't know where it's located, but it is somehow converting this into a float that is then grabbed in there in order to get your dense or sparse animations. However, at the moment, if you do need to make adjustments on what is played, or like especially if you make a new motion matching table and you throw it into that chooser table, if you did see my video on that, you do want to update this appropriately so that way it chooses whatever you want to start it at. So if you put your newly created motion matching table as the first option, make sure that this is set to 0 so that it plays that. But if you added it in as the third option and you want that to play instead and you don't want to move it or anything like that, then you would need to change this to a 2, which then transforms somewhere. Like I said, I haven't found it yet, but then it will play that new database that you have input if you have a new database. So once we have that, let's go ahead and plug in our pin to that. And we are essentially done with that section, and we are now on to the final section of this video. So basically what we're going to do now is we do have to get another plugin for this. So I am going to compile and save. So for this to work, because we are doing a validated get on this in order to do specific things, is we have to get the pose search plugin for this now. So off of edit and plugins, look for pose search and grab this, and it will prompt you to restart once you do that. So go ahead and do that, which is what I'm going to do right now, and I'll see you when I get back. All right, everybody, I am back. So now we are going to create our final essential values. So let me go ahead and move the last non-zero in here and the lot in here. I do see that I misspelled it, so let me fix that real quick. All right. So now what we have to do is we need to create a new variable that we are going to call current selected database. Make sure I spell this right, database. And what we are going to do is we are now, because we have the pose search plugin, we now have the capability of searching for the pose search database. Oop, if I can spell. And we want this object type right here where it says pose search database, and we are going to grab an object reference. So I'm going to put this together first, and I'll explain what we're doing as far as this is concerned. So let's go ahead and drag a get reference into here, and we're going to turn it into a validated get because we want to ensure that the current selected database that we were trying to grab is valid. So then off of that database, or off of this get current selected database, we want to do get tags, because what it's going to do is it's going to go through the database and get an array of tags that it's going to, go through to where we can then now do a set for current database tags. So go ahead and promote that to a variable, and we're going to call it current database tags. And then let me move these briefly into essential values. And currently we have everything that we need. So now what we are going to do is let me briefly go over what's going on. So with the validated get, what we are doing here is it is a reference to the active pose search database used for motion matching. A pose search database contains animation data organized in a way that allows for precise selection of animation poses that match the character's current motion. The validated get part ensures that the database exists, is not null, before trying to access it. This is a safety check to prevent errors if no database is currently selected. So for the get tags part of this step retrieves tags from the selected database. Tags in a motion matching database can represent different states or contexts, such as running, jumping, or idle. Tags are essentially metadata associated with animations in the database and is used to help narrow down which animation poses are to be used based on the character's current situation. So in this case, the tags are being pulled from the current selected database. Then what we are doing with the set node is that after retrieving the tags, they are stored in the current database tags variable, and this variable serves as a cache, allowing the animation blueprint to reference these tags during gameplay without having to requery the database each time. So the cache tags help the motion matching system make animation selection decisions more efficiently by filtering poses in the database based on the current state. For example, motion matching animations that have running tag when the character is moving. So that is essentially what is going on with these three nodes, and it is a lot to take in. So that's why in the dev notes it says caches the tags from the currently selected motion matching database, and it allows us to make additional selection choices based on the current database. So now that I've gotten that all out of my system, I'm going to go ahead and put in the comment for y'all to copy down for your own projects. That way you know what's going on, because this is basically the notes that I read off of for you to understand what is going on here. So now I'm going to move that in here, and I am going to add a new pin and make that connection. So I am now going to compile and save, and I can officially claim it done for this video, as we have now went through the essential values part of the Animation Blueprint's event graph. So I know it was a long-winded, great first start of a video, but hopefully now you see what is currently going on in the update essential functions part of the game animation sample project with all those variables. So like I said, not all of these are being used. A lot of them are being referenced in certain places, but all of them are just being stored for later use. So meaning you can create your own functionality to be able to use some of these referenced objects or set variables within your own databases, your motion matching databases, or do other cool stuff with if you're more advanced as far as setting these up. So with that being said, one last adjustment we can make is we can then go back out into our Anim Graph and convert this should move to, where is it at? It should be, if I click here, I'm trying to get the has velocity. I believe we can finally use that now. Yeah, has velocity. Because essentially what we are doing now with this, as you can see in here, from what we called right here, right, where if our ground speed is greater than 5, we have velocity. So in the actual Anim Graph, within the game animation sample project, if we pull it up and take a look at it, so if we go into the Anim Graph, you can see that it has an is moving function. We will get to that in one of the videos. However, currently right now, we just want to have the has velocity, so that way it can, as a basic way of saying that we should be moving, because we will be creating all of these functions and calling them in here. So once you have that changed, you can go ahead and in the update essentials values, go to the default anims, and actually essentially what you can do is pretty much, let's just go out of here, back into it, and we can technically just delete this because we're not using the is falling, or actually no, I'm sorry, we are currently using the is falling. So for the moment, because we want to keep those basic animations, just delete the should moving, and you should be fine. So now that we go through, well, it will break the animations. So in order for you to keep the animations, we do have to go into locomotion, and we have to change the should move to has velocity. So I'm just going to make those basic changes real quick for y'all to have for your own locomotion, for you to keep these in check, or to at least keep the animations working. Cool, now that I've compiled and saved, if I hit play, you can see that it is still working even without the should move, and we have our experimental offset anim node working. So that, like I said, guys, that's pretty much it and a good first run to a first video. I'm hoping that you really found this educational, and hopefully I explained it, you know, well enough for y'all to understand what is going on essentially in that first function. So if y'all did like that, guys, please tune into my other videos. Also, too, for some of the parts in here, I highly recommend going through my character blueprint series. If you haven't already, I know it's a bit cringy to go through because those are my first videos starting out. I have gotten better at doing the recording, so please bear with me on those videos, but I do recommend checking those out if you haven't already. So other than that, guys, y'all have a great rest of your day and take care.